Okay, so we're going to now talk about the concept of natural breaks as a classification method. And the easiest way to describe natural breaks is intuitively, it is a system where we look for actual troughs in the histogram of the data. And in those troughs, we're going to put our breaks. That is, to look where the natural divisions in the data are. Now, George Jenks, who was a professor of cartography at the University of Kansas in the 1950s, developed an actual quantitative approach to this where he maximized the variation in each class. And he did this iteratively. That is, he put the breaks in, calculated the variation, and then changed them to see whether or not that increased or decreased the variation. Now, today, computer software does this for us, and as a result, what we end up with is very good and very quick ways of calculating natural breaks. Now, the downside to this, of course, is that if our data doesn't have kind of these well-defined troughs, sometimes our breaks are put in that appear, and in some respects really are, fairly arbitrary relative to the real distribution of the data. So when we see it kind of in a theoretical histogram, what we would look at is something like this. So in other words, if we wanted to put 5 breaks in, what we would do is look for the troughs in the data's histogram, that is, the number of events in each value that have a given value. Now, the good thing about natural breaks is that it makes sense to people when they look at the histogram. These gaps certainly make sense. The downside, of course, to it is that the breaks, the interval, then, because the breaks are put in naturally, the interval may vary considerably. And the other problem, of course, again, as I said, is that if the data is fairly evenly distributed, while a computer and the algorithm will generate the breaks, those breaks may effectively be an arbitrary or almost a random placement. All right, well, let's take a look at this. And so if we look at, I'm going to start with our natural breaks. Again, this is on 5 classes. And again, it's our population data in our block groups. And in this case now we're seeing, again, natural breaks, 5 classes. And if you'll notice the difference in the classes, 0 to 39 for our first one. And if you remember previously, in our equal interval, that first class, and in fact all classes, had 318 as its interval. And so in this case, we're significantly breaking that low end. And if you remember that histogram, that low end, we're breaking it apart quite a bit. In fact, our first, second, third, and a good portion of our fourth class would have fit into the first class of our equal interval classification. And so as a result, we see much more variation in this area up here. In other words, we can really see the fine breaks in the low population values. What does happen, however, because we have fewer values and they're more spread out at the upper end, you'll notice that we have a lot of data that appears in this last class. These infrequent events kind of get clustered together. And in fact, if we look at the histogram of this set of data, what we're going to see is just that. Here's our, in a sense, we really have an outlier here, and then we have individual events scattered throughout here, and all of them get clumped together, 595 to 1591. And in fact, the same thing really happens in this fourth class, where quite a range of data, 230 to 595, again, get clumped together. But again, this approach does effectively deal with the small group. But you'll also notice right here that it's kind of hard for us to see why these breaks do occur. And so to some degree at the lower end, our breaks are less defensible. All right, now, the other thing that does happen, though, is if we look at a normal distribution of data and then natural breaks, we're going to see, and what I've done here is we've tossed out any of the data that doesn't have a population in it. But when we look at the distribution, well, now we can actually see some of these breaks in the data. And you'll notice right here a nice trough that appears, and here's another trough here. And so that's where our breaks occur. Now, in this case, there's still some outliers, and so that last one exists across a broad range, but it makes a little bit more sense. And again, in the natural breaks, we can certainly see the variations across space. It's very clear to pick out the intervals across each of these. And so again, natural breaks has its advantage. It allows us to see variation where things are somewhat clustered. It assumes, though, that there are natural troughs in the data. All right, we'll see you next time. We're going to be talking about standard deviations.